Thank you very much, Johanni. I appreciate the invitation. This is the second time I've now been able to come to Helsinki, and it's always a very humbling experience to see the seriousness of these events and the fact that they result in publications, and it's very unusual to have something like this every year. And I think it's something that I'm sure many of you look forward to, the results of these. Now, I was asked to choose a topic, and I chose the topic of culture, and I did specifically because it's a word that almost does not appear within recent architectural theory. And I'm, of course, coming at it as an architectural historian. And so I would like to just sort of open with the observation that the history of architecture is not the history of buildings or building styles. It is rather a history of ideas and how they have shaped the way that we think about the world and how we think about ourselves. These ideas, I think we all agree, are always shaped by larger cultural forces. Can everyone hear me all right? And what is most interesting about this connection, I think, is that those periods in which the design arts have most profoundly experienced change have been those periods in which architectural theory has emphatically been defined by cultural ideas. We can look at the first millennium of Christian Europe, which resulted in Ravenna and Constantinople, and later the large Gothic cathedrals. The humanist theory of Leon Battista Alberti in the 15th century was directed to reinvigorating the same culture and yet eliminating the Gothic traditions and returning to classical Roman forms. In 18th century Europe, an upstart Greek-informed coalition led by J.J. Winckelmann, Marc-Antoine Laugier, and others square off against the aristocratic taste of the late Baroque and Rococo architecture, a cultural battle that was mirrored by the many philosophers of the European Enlightenment. And in the 19th century, Louis Sullivan embraced the cultural polemics of Ralph Waldo Emerson and Walt Whitman and passionately argued that architects should work toward a new and uniquely American architecture in line with the newly founded democratic ideals of the United States. The idea of modernity similarly transformed architecture around the start of the 20th century, and one can even argue that the various architectural debates of the 1960s were in fact manifestations of a larger cultural war, one in which the collectivist European typologies of Aldo Rossi squared off against the American populist polemics of Robert Venturi, one camp calling for a simplification of form predicated on pre-industrial European and planning methods, the other for an anti-establishment architecture critiquing the values of a social culture collapsing under great duress. But then something happened to architectural theory not too long after the 1960s. Postmodern and post-structural theory was profoundly hostile to the very notion of grand narratives and cultural theory. And it would only take a few years before architecture would seek its inspiration in ponderous philosophical abstractions on the one hand, and with the new possibilities afforded by computer-based software technologies on the other hand. So let me just begin by raising the question of whether architectural theory can ever again reconcile itself with cultural theory, and if so, how might this happen? So in doing so, I'd like to start with the observation that over the last 3 decades in particular, cultural theory has itself undergone a radical transformation in its values and methods, as the quest for social facts or the effort to connect individual behaviors with larger societal institutions are no longer seriously pursued today, and few would define culture as a symbolic system of norms regulating the way that we think and feel, a societal add-on to our genetic structures. Now, what happened to cultural theory was in fact the infusion, I guess, of biological ideas into what previously had been autonomous and speculative, or the autonomous and speculative domains of sociological and anthropological theory. By the end of the 1960s, few authors from outside of sociology proper offered the tenet that we were not the rational creatures that we had for centuries presumed ourselves to be, that we had certain behavioral patterns that were not really a product of cultural programming. In the early 1970s or the mid-1970s, Edward O. Wilson made a rather shocking proposal, one that engendered enormous hostility within academia, when he noted that if sociology were ever going to be taken seriously as a science, it would have to draw upon the recent insights of genetic theory. And not long thereafter, we have the birth of theories of gene-culture coevolution, in which culture can no longer be detached from a biological foundation. By the 1990s, we have a rather dramatic collapse of classical anthropological and sociological theory, and a number of new and interesting interdisciplinary fields taking shape, such as evolutionary and social psychology, evolutionary biology, neuroaesthetics, and niche construction, the last of which is based on the premise that just as we alter our environments, so do our altered environments change the structure of our beings. Around the same time, we have a number of significant discoveries within the biological sciences, the implications of which are still being explored and debated today. No one, however, will dispute that the understanding of who we are at this time is vastly different from the portraits that we painted of ourselves back in the 1960s. And today I would like to make the case that architects have something to gain from looking toward the new cultural theories taking form. And to do so, we will have to broaden our theoretical horizons and look outside our field to where we can draw upon, I think, a number of new and very important insights. We have to admit that the idea of culture today is no longer a one-dimensional narrative with a single-minded focus, nor can it be reduced to a few speculative tenets or patterns of behavior. So let me begin with, or at least propose a beginning point, which is our own sort of evolutionary timeline. Only a few years ago, it was a consensus of many anthropologists that Homo sapiens underwent a major cognitive breakthrough around 50,000 years ago, which resulted in such things as the cave paintings of southern Europe, complex language, and other symbolic forms of cultural transmission. Today, we take a much longer view of our past, and for many reasons. If we broaden our timeline out to millions of years, we gain a very different perspective of who we are and from where we came. Those footprints of Lucy recorded in the volcanic ash of Tanzania 3.6 million years ago already portrayed a semi-erect species who had moved away from the tropical forest of our primate cousins. Another set of major adaptations came about with the beginning of the Homo genus around 2.4 million years ago. And in relation to the past, modern human development looks quite small in evolutionary terms, a mere 200,000 years that Homo sapiens has walked the earth. If we look at the growth of the cranial capacity over the same time frame, two other things stand out. One is that up until the species Homo habilis, the handyman, the brains of our ancestors had not enlarged much beyond our primate cousins. The cranial capacity of Lucy, for instance, barely outstripped that of a modern-day chimpanzee. The second is a massive jump in brain sizes, with three species in particular, beginning with Homo erectus, who appeared around 2 million years ago, and I'm using that designation in its broader sense because there are several sort of species around the same period of time. We have the jump with Homo erectus, and then we have another significant jump with Homo heidelbergensis, which appeared in Africa between 800 and 600,000 years ago, and I will just refer to them as the Heidelbergs. And then, of course, we have Homo sapiens coming about with a very short sort of evolutionary timeline. But brain sizes in themselves do not tell the whole story, and restricting ourselves to the last three species, we can learn much from their social and cultural behaviors. Homo erectus not only enjoyed a brain almost double the size of that of the pre-Homo species, but his toolkit, which remained little unchanged over the course of his lengthy timeline, was obviously not the driving factor for the brain increase. Yet the social behavior of Homo erectus was strikingly different from earlier species. He hunted in larger groups at far greater distances in time and space, which necessitated enhanced communicational and group coordination skills much beyond that of apes. With his much enlarged body and brain size, he also needed greater nutrition, which eventually necessitated the introduction of meat into the diet and the invention of cooking to make these high-protein foods more efficient for digestion. There may well have been other social behaviors associated with this species, such as laughter, imitation, or other aspects of what Merlin Donald has called mimetic culture. If we turn to the African Heidelbergs, let me go back just a second. Which is the middle species here, we find another large increase in brain volume and more complex behavioral patterns. In fact, behavior is not far removed from those of ourselves. Again, we have an increase in group activities and social communities. Trade comes into play. Anatomical changes in the vocal cord and the ear canal announce the rudiments of more sophisticated speech. And the use of ochre suggests probably some form of body ornamentation. And when we combine these behaviors with the complete mastery of fire, for which we have solid evidence beginning around 500,000 years ago, we have other implications as well, such as the likely appearance of music, song, and dance, to which I want to return to shortly. The appearance of modern humans in Africa around 200,000 years ago, again with larger brains, no doubt drew much from these earlier cultures and social behaviors. But those things that we hold up today as unique to human behavior, such as symbolism, complex language, the creation of artistic representation, were really more than icing on the cake, as it were, and that's a cake that had been baking for the last 2 million years. The foremost question of evolutionary history today is what exactly drove these evolutionary changes, not over the last 50,000 years, but rather over the last 2 million years. And the consensus that has been emerging in the past 2 decades is that the single most important factor driving human anatomical changes and cognitive development was the increasing complexity of our social life, which in a few important ways is quite unique among the higher primates. Let me take the case of Michael Tomasello, the co-director of the Max Planck Institute of Evolutionary Anthropology in Leipzig. He's an interesting anthropologist because the focus of his research has been in 2 areas. One, early childhood development, and then secondly, in primate cognitive development. And whereas many primatologists emphasize how close we are to our great ape cousins in our behavioral patterns, which is true to some extent, Tomasello offers a different perspective by making the case that human cognition developed in one way quite unique within the primate world. Early in our evolutionary history, around 2 million years ago, he argues, we initiated a process of cumulative cultural evolution, that is, the ability to take creative inventions and pass them down to succeeding generations where they are in turn modified and improved. And the reason that we were able to create this ratchet effect, as it were, was because we developed one social skill that apes did not develop, which is the ability to see other members of our species as intentional beings with mental lives similar to our own. This unique form of social cognition becomes evident in children around 9 months of age. And by 2 years of age, children already outstrip mature primates in their ability to commune with one another in a process of joint intentionality and cooperation. He argues that we probably began to develop this skill with the beginning of the Homo species, and with the Heidelbergs came more sophisticated communicative tools such as pantomime, simple representation, inference, and self-monitoring, as well as a willingness to conform and bind with others in social groups. His argument is really a variation on niche construction, that just as we change the facets of our cultural context, so does our ever-changing cultural context alter our cognitive structures. Robert Dunbar's social brain hypothesis makes a similar case, but from a different body of evidence. He first put forth his hypothesis in the 1990s, but it has since been developed in greater detail with others. His original question was, what were the evolutionary factors that could have led the enlargement of an organ, the human brain, which consumes 20% of the body's energy production while possessing only 2% of the body's mass? Dunbar's answer effectively turned conventional evolutionary theory on its head, because his hypothesis is that we are by nature social animals, as Aristotle said several thousand years ago, and the social complexity of dealing with our ever-expanding social networks, our families, friends, enemies, clans, and larger social alliances is what compelled the brain to expand its cognitive powers to cope with this social reality. Now, both of these hypotheses are almost 20 years old, and they were very important breakthroughs within the context of cognitive theory in the 1990s, much of which was then predicated on the computer-inspired hardware-software models of human cognition. But neither hypothesis seeks to explain what biological factors within early humans allowed this particular social turn. And whereas instrumental factors such as the climate or the ecology of the African savanna certainly played a role in our social development, the neurological structure of the human cognition in itself had to play a similar role as well. Now, around the time that Tomasello and Dunbar were making their case, philosophy was also going through an interesting transformation, and I'm speaking about the 1990s. We are, as Edmund Husserl noted many years ago, animate organisms, sensorially and emotionally attuned to our surroundings. Yet the predominant line of thought throughout most of the 20th century was its almost exclusive focus on the rational processes of human cognition, the reduction, in fact, of cognition to this single capacity. Theories of embodiment first appeared as a way to counter this bias, first by emphasizing that we have affective and emotional dimensions to our cognition, and second by underscoring that the perceiving body is not just a conventional biological housing for our mental engines. The body, in the most fundamental and obvious way, shapes our very thinking. Francisco Varela and Evan Thompson reintroduced this premise in their important book of 1991 on embodiment, and by the turn of the century they sought to frame their phenomenological perspective within a more encompassing biological framework in which the nervous system, the body, and the environment are highly structured dynamical systems. And they are so thoroughly enmeshed biologically, ecologically, and sociologically, or socially, that a better conception of the brain, body, and environment would be as mutually embedded systems rather than as internally and externally located with respect to one another. In the same article, and this is, I think, an article that was published in 2001, they made the point that these three embedded systems operate in 3 cycles. And because the brain, body, and physical and cultural environments are fully integrated with each other on multiple levels, the developmental process of human life reconstructs itself anew with each generation in response to the ever-changing genetic, cellular, social, and cultural factors. The body, the brain, and the environment are in fact co-determining of each other and therefore co-evolving. Now, with these three cycles, the first is an obvious cycle of homeostasis that every organism has to maintain with respect to the environment. Cycles of sensory motor coupling between the organism and the environment are very, I think, important for architecture because we are, in fact, the creators of the environments that we inhabit. And so this, I think, in itself opens up a very large area for research. But what I would like to focus on today are these cycles of intersubjective or sociocultural interaction with others. Because, again, this is something I think that has been a little missing from architectural theory for some time. Now, around the same time, there were a couple of other things that began to change the way that we look at ourselves. The first was really our transformational understanding of emotion, not as a dialectical antithesis to reason, but rather as reason's very, very biological foundation. Emotion as a pre-reflective electrical chemical process that shapes the way we see the world, basically as a pleasurable or non-pleasurable organismic experience. I put in the most simple definition of emotion that one can find, which makes its transposition to architecture also a very simple one, the response of an organism to a built environment. So we have the idea of emotion becoming very prominent around the turn of this century. But the second, okay, I didn't have that up there before. But the second event at the same time was the discovery of mirror mechanisms, which took place in a lab at the University of Parma in the early 1990s. And it was a discovery initially found not in humans, but in macaque monkeys, and we know that we now know that several other species also possess these mirror mechanisms. If we define the mirror mechanism as Professor Galeazzi, the preeminent authority in this field, will no doubt expand upon later, they are motor circuits within ourselves that become active when we see someone performing actions, as if we were simulating or performing the action ourselves. If we see someone pushing or pulling a heavy block of stone, for instance, parts of our premotor and parietal cortices become active as if we were pushing or pulling the stone. And by the way, this is a lost painting of Carl Friedrich Schinkel, where we do have a copy of it, but the original has been lost. If we see implements such as an egg beater or a hammer, we simulate the action involved with the tool, presuming we have some familiarity with it. Now, around the turn of the century, the issue for many cognitive or neuroscientists was whether mirror or other such mechanisms contribute to the reading and sharing of the emotions of others, such as when we watch a sad movie, our eyes may well with tears. Psychologists have defined this simulated process as one of empathy, and it is defined primarily in psychology as the ability to read or attune oneself with the emotions of others. Soon there began a series of experiments designed to seek out the neurological basis for this centered subjectivity, such as how watching someone exhibiting the expression of disgust, for instance, activates circuits in our own interior insula and anterior cingulate cortex areas relating to the processing or monitoring of our own feelings of disgust. Now, this problem is interesting because it is a complex one, and first because human empathy possesses deep evolutionary biochemical and neurological underpinnings, activating the cortical areas of the brain, but also the limbic areas, brain stems, the autonomic nervous system, and the endocrine systems. Second, because it also involves the so-called executive areas of our brain, that is, the representational and meta-representational mechanisms of our advanced social life that are of much later evolutionary vintage. Nevertheless, the scope and intensity of the current discussion again underscores how fundamental, empathetic, or the simulating processes are to our beings. And this social awareness seems to be active with twins in the womb as early as 14 weeks after gestation, as one recent study has demonstrated. And again, Professor Gillespie was one of the authors of the study. But note how this particular discussion has transformed our perception of ourselves. Mirror mechanisms are embodied circuits which were present in our primate ancestors, not only facilitate our connection and understanding of the world through our simulative responses, but they also help to explain the processes by which we become the social animals that we have. That is, by bridging the cognitive, sensory motor, and somatovisceral dimensions of our biological evolution. We inherited certain biological and neurological mechanisms from our primate ancestors and developed them in a uniquely human way, at the same time cultivating a new and more complex social cognition distinct from that of our primate cousins. With such a model, we have the prospect of a unifying philosophical model of social cognition predicated on intercorporal relationships, one in which motor and emotional cognition become key factors in our social relations while also fostering a sense of self, as again this particular paper argues. Now, what I would like to do is sort of turn this back toward architecture. And in my limited time, I wanted to focus really on one aspect of empathy, which is what I will call, or I have called here, aesthetic attunement. And I'm not sure I really like the term, but I may or may not use it sometime in the future. In any case, the great Dutch architect Aldo van Eyck often encouraged designers not to speak in such abstract terms as space and time, but rather to see design in a more basic social way as a making of place and occasion. The point that he repeatedly stressed is how deeply rooted into our human natures is this impulse for social interaction in communal expression, and how important it is for the architect, who is the designer of the built environment, to recognize this social aspect of our nature. So I would like to consider it first by returning back to this particular timeline with respect to the Heidelbergs, where I made reference to music, dancing, ornamentation, and the practice of architecture as much as 500,000 years ago. Now again, Homo sapiens is about 200,000 years old, so we're already twice our vintage, as it were. But let's take the case of architecture. In the 1960s, a Paleolithic settlement was unearthed under the present city of Nice, where the outlines of a number of timber huts with center posts were found. Some of the huts were over 12 meters in length, and each had a hearth inside. The Mediterranean community was occupied by the Heidelbergs and has been dated to 380 to 400,000 years ago. Similarly, over the last 30 years, excavations have unearthed a lakeside settlement in central Germany that revealed the footprints of 3 rounded living structures with hearths outside and with their doors oriented away from the predominant wind direction. There were also several workshop areas with a large circular paved area approximately 10 meters in diameter where ritualistic events seem to have taken place. The occupants of this village were not Homo sapiens or Heidelbergs, but rather late members of Homo erectus, who 370,000 years ago or so had survived the colder ecological conditions of the interglacial period and prospered. In a cave approximately 45 kilometers west of Barcelona, extensive diggings have been undertaken and are still ongoing. Archaeologists have uncovered a rich collection of artifacts. On one particular level was found the imprints of timber beams, timber posts, presumed to be part of a lean-to structure built against the rear wall of the cave. Inside the outlines of the structure were 5 hearths, 1.3 meters apart, around which 4 to 6 family members likely gathered. Vegetal deposits have been found for what are believed to have been the remnants of grass beds, suggesting a cozy cave community inhabited somewhere around 55,000 years ago. The occupants of this cave were not humans, but rather Neanderthals. Now, my point in bringing these three examples together is simply to demonstrate that many, if not most, of our human instincts, including that for building structures, are older and more widespread than our particular species. And the common denominator in all three examples is the hearth, what the 19th century architect Gottfried Semper called the social motive of architecture. His central premise, first articulated in 1851, was that there were four primordial motives underlying architectural design: the hearth, the flooring, tectonic structure, and walling. The hearth was a social motive because it was around the fire that the first humans gathered after the chase to enjoy a meal and engage in social activities. The three other architectural motives involved in order to protect this social motive: mounding, or the making of a stone platform, raised the fire off of the damp earth; a structural framework supported a shelter overhead; and vertically hung textile wall mats protected the flame from the wind. But if there is a hearth and people had gathered around it to keep warm or enjoy a freshly killed reindeer, what else did they do? Surely there was some kind of social exchange a million or two years ago. Now, of course, nobody really knows when the first member of Homo erectus fell into a dance, but the fact is that Homo erectus had an erect frame, good musculature, and the physical endurance well suited to dance, and it is highly likely that he danced. Similarly, no one will ever know when the first human ancestor employed a bone to make a rhythmic beat on a tree trunk or a hollowed log, but we can assume it was very long in the human or pre-human past. The mere exercise of walking upright on two legs cultivates a sense of rhythm, something deeply embedded in our actions and sports. Once again, no one really knows when a mother, flush with a veritable soup of endorphins manufactured by her pregnancy, first hummed a quieting song to a newborn infant, but no one will dispute the universal affiliative interactions between mothers and infants, the rhythmic coo-cooing patterns in a high-pitched voice, accompanied with hand and face gesticulation and playful touches. Certainly they go back well beyond Homo sapiens proper. We have evidence that our ancestors employed fire possibly 1.6 million years ago, and we have widespread evidence of large communal hearths beginning around 500,000 years ago. So again, I raise the question, what did early humans do around the fire? How did they socially engage with other? And I think the answer has to be that more than likely they devised the rudiments of the ritual and temporal arts. Neuroimaging today is revealing that the circuits for processing music and language overlapped and are intertwined, suggesting that music and language likely arose as two related forms of human vocal activity. The anatomical changes allowing nuanced vocal expression, the drop of the larynx, the hyoid bone, and the size of the hypoglossal canal, the rounding of the rib cage, and the development of the thoracic respiratory muscles allowing extended expiration, all were well on the road to their human formation around 1.5 million years ago, although all were not really fully evolved until about 100,000 years ago, which of course points to the long and progressive development of the artistic instinct. One of the implications of human empathy is that it demonstrates just how attuned we are to each other socially, how being around another person, for example, can awaken a mood or alter a mood within us. Many writers have attributed the same power to architecture, that is, how a good architect informs a built environment with a large range of potential moods. And Johanni Plasma, Peter Zumthor, and others have invoked the term atmosphere in relation to architecture. The atmosphere that a good architect fashions. Socially and culturally, then, one could argue that architecture is nothing less than the creation of a mood. It is the making of atmosphere for a ritualistic setting, a place for one to feel at ease, to be oneself, and enjoy one's life. And this leads me to a further aspect of Semper's theory, which was the fact that it was a preeminently a cultural theory. In his introduction to the main work, his main theoretical work, Style in the Technical and Tectonic Arts, which was published in 1860-63, Semper spoke of architecture's origin and our primal delight, as he notes here, in the rhythmic sequence of space and time movements, the wreaths, the string of the pearls, etc., etc. If we go to the main body of text, Semper sought to underscore the evolution of these motives through virtually every known culture, or every culture known in his day. Everything from Assyrian warrior helmets to Greek and Egyptian vessels to the Weeping Wall of Jerusalem to Maori tattoos and Scandinavian staved churches. Yet there was one motive that was particularly dear to Semper, which was the textile or walling motive, because for him it was inherently aesthetic in the very action of its creation. It was already artful when the first hominid strung two branches into a wreath or wove two different colored grasses into a mat. Semper also believed that this motive underwent extensive cultural refinement in a variety of ways, leading to the principle which he called Bekleidung, or the act of dressing a work with aesthetic or atmospheric sensibilities, which for him achieved a particularly brilliant apotheosis in Hellenic culture. In his lengthy excursus on the theme of Bekleidung in his book on style, he in fact opens a discussion with a commentary of Hellenic clothing. He cites a fragmented passage of Democritus, who comments on the violet, blue, purple, and saffron yellow patterns displayed in the undergarments of the women of Ephesus, which Semper follows with a detailed description of the beauty of the draped peplos and Doric chiton. These observations on clothing may seem remote from the practice of architecture, but Semper's point is precisely the opposite. If the jewelry and drapery of the Ephesians had attained such exquisite refinements in their lines, materials, and coloration during this period of art, the ornamental dressing employed on polychrome monuments must also have been similarly inspired. In short, Greek garments and Greek architecture arose from one and the same artistic culture and exhibited the same refinement of aesthetic consciousness. These ornamental and sartorial examples for Semper were also captured in the Greek temple. And last page, where he talks about the creation of the monument, the festival apparatus, which he describes as the improvised scaffold with all of its splendor and frills that specifically marks the occasion for celebrating, enhances, decorates, and adorns the glorification of the feast, and is hung with tapestries dressed with festoons and garlands and decorated with fluttering bands and trophies, that this festival apparatus is the motive for the permanent monument, which is intended to proclaim to some future generations the solemn act to be celebrated. It is at this point that Semper inserts his very telling footnote on the dressing and the mask. The motive, which for him that was as old as humanity, and the act of masking was the quintessential artistic expression of human culture, enshrined in every cultural event from the narrative sculptures of Phidias to the dramas of Shakespeare. And I just cited one small passage here, that every artistic creation and pleasure presumes a certain carnival spirit. The haze of carnival candles is the true atmosphere of art. Now, the point that Semper makes here is precisely the point that we should bring into our thinking today, which is that if indeed our early human ancestors engaged in laughing, singing, dancing, and musical rituals as early as 1 million or 2 years ago, we should at least, or at last, recognize ourselves for the singers, dancers, and social performers who we really are. Who in the world am I, Lewis Carroll once asked. A newly formed body of psychological and cultural theory is beginning to identify crucial pieces of that great puzzle, although such an understanding from an historical perspective is not all that new. Thank you.